field, it protects us up to 11 Earth radii. That means Earth's diameter is 12,000, around more than 12,000 kilometers. So that means, up to 60,000 kilometers, this magnetic field protects us. It's there. But when a plasma comes towards Earth, it compresses Earth's magnetic field. And when the plasma is, because plasma is charged particle, it produces a geomagnetic storm. And in 1847 or so, there is one Carrington event. That is, the person named Carrington event found out. When it happened at the time, they did not have power lines, etc. But they had this telegraphic lines. It picked up and it destroyed all the instruments. So if such kind of event occurs, all our electronics, if it's switched on, it will pick up this rays and it will destroy all electronics, all GPS system. No, we cannot use our mobiles to navigate. We cannot use satellites. This charged particle will destroy everything that has to deal with charge, like electronics, electrons, and many other things, power lines, etc. So that's why, people study this kind of events so that we can protect ourselves. So before such an event comes, we can switch off all those electronics. So this kind of study is called space weather. Then we'll see what we know. Most of you have studied about solar system. So here you see the Earth rotating around the sun. It's not according to the size, but if you see the last planet, it hardly moves when Earth completes 1 year, one rotation around sun, which is 1 year. Whereas Mercury, Venus, it moves much faster. So, a planet like Jupiter takes 12 years to make one rotation around sun. So a year on Jupiter is 12 years, whereas Neptune, it's 164 years of Earth years, our years, for it to make 1 year in life on Neptunus. So if you see, here you see different planets rotating about its axis. For example, for us, one rotation is 1 day. There are some planets which rotate much faster. For example, Jupiter takes only less than 10 hours. So a day in Jupiter is less than 10 hours. Whereas a year in Jupiter is 12 years. So similarly, if you see Neptune, it takes 16 hours. A day in Jupiter is 16 hours. Whereas a year in Jupiter, in Neptune is 164 years of Earth years. So we see so many intricate details, even in our solar system, which we can observe. We have sent satellites, we have sent probes to see those things. Okay, our sun is in Milky Way. So we all know Milky Way. If you see, if we take a Milky Way photography, for example, those of you in southern hemisphere or near equator, if you go to a pitch dark sky and expose your camera for some time, you can see a structure like this, if you know where the Milky Way is. But if we look from the top, it looks like this, a spiral galaxy. And this is our center. In the center, there is a big, massive black hole is there. Sun is in one of its arms, the spiral arms. Sun, it is almost 25,000 light years from the center of our galaxy. So most of the stars that we see is around this area. So why do we see? Because of, if this is the galaxy, our Milky Way galaxy, our sun goes around the Milky Way galaxy like this, no, slightly elliptical, similar to our Earth going around sun. That's why we get summer and winter. And it takes, sun millions of years to complete around our galaxy.
Sir, can I ask you a question?
Can I answer at the end? Please write it in a chat.
Okay, sir.
And you see, the Earth makes an axis to the axis of galaxy. That's why we see the Milky Way in a slanted position. For example, like if we make our Earth rotation is something, equatorial, like what we know, then our Milky Way look like something like this. But most of this picture is taken from the satellite. The Milky Way looks slanted, based on where the satellite is and from what position we take it. So then in space, size matters. So here you can see the size of different things: Moon, Mercury, Mars, the diameter of it, Earth, 13,000 kilometers. This is an exoplanet, and Uranus, Saturn, and Jupiter, the biggest planet in our solar system. Then Sun is a dwarf star. Then we have Sirius, giant star. Look at the size, how Sun looks so small. And we still have massive objects like Antares we can see with naked eye. Okay. So then you see, no, supermassive black hole, how big it is. And you see the size of nebula, and you can see different nebulas of different size, and even this dark galaxies. And even Milky Way seems to be bigger than many of those galaxies. Then you have hyper galaxies, which are much, much bigger than our Milky Way galaxy. Then you have this big universe, the space. So you see this Milky Way, in different positions we saw. Okay, so now Milky Way itself has a lot of structures, which we came to know some, decades back. You see the Milky Way, then we are accompanied by two satellite galaxies, smaller satellite galaxies. They are called large Magellanic Cloud and small Magellanic Cloud. And they have a gas, one leading arm and this one Magellanic stream. And there is one big explosion happened in the middle of our galaxy. Some scientists say millions of years ago, a million years ago. Then, a big massive star was captured by a black hole, and big explosion took place. Because of that, the gas spread upwards and downwards, and there is a glow that we see. It's called this Fermi bubble. So we see a lot of these events, etc. And Milky Way itself is 150,000 light years. Okay, so light year is, I don't know, you guys must have heard in your class about the speed of light. Speed of light is almost close to
3.0 times 10 to the power 8.
Okay, 10 to the power
8.
8 meters or okay. So anything you say, you need to know the unit. So whether it's kilometer or meter per second, etc. Okay, we are talking in terms of per second. So it takes light 1 year to reach that place. So if a light is produced at one side of the Milky Way, it will take 150,000 years for the light to travel from one end to the other end. Not this vertical wise, but horizontal, because ours is a disk kind of galaxy. That because of rotation, gases they form like a disk. So that's why in nature we see mostly the galaxies in the shape of disks. Okay, so
What is the unit for the speed of light in space?
all questions, can we see it at the end? Because I need to cover fast. If I address one, then I have to keep. So unit of light is in terms of meters per second. Okay. So all questions you please put it in the chart. Then I will try to answer, because if we start addressing the questions, then we won't have time to cover all the topics. Okay, so here we see the different structures of the universe, that we see in universe. Uh, if you see this M82 is a galaxy, and the galaxy is oriented in such a way, like, as I told you, like a Fermi bubble kind of thing. We can easily see in this galaxy when a new star forms, a new explosion takes place, how it propagates, etc. And this able to 744, the names are either the person who cataloged or saw it first time and cataloged, or a satellite. So basically the names goes in that way. So so Abel is a cluster of galaxies. So each, the bright thing that you see in this one is more of galaxies. You can see galaxy. So you see this elliptical structure kind of thing. Then this is a supernova event. Supernova event is supposed to be the brightest event. When a supernova explosion takes place, the light, it surpasses all the light in the universe. It's so bright. And this is a supernova. It's supernova 1987, means it happened in 1987. And this is the remnant of it. And then you see this one, this star about to explode to a planetary nebula. So we'll see the life cycle of a star later on. And here you see another galaxy. You see this gas. So this gas, when the star exploded, when the galaxies formed, this gas, it started spreading out. So you can see how much the gas has spread out from the galaxy. So when you go back in time, they would have originated from the same time. So this helps us to understand the formation of the galaxy and the structure of the galaxy, etc. So then this nebula, so this is like sun, like a star. It's running out of its fuel, and again it's expanding. And after some time, the inner core will shrink and form a white dwarf, and the outer core will spread like a nebula and slowly starts forming other stars, new stars. So we get to see a lot of information from the photos. Okay, so scientific investigation, the fundamental questions. So when we look at an object, we ask this question: what it is made up of? How does it work? Like, what is the composition of sun? And how does sun give light that we see, or energy? So then why sun? Why not Jupiter? We tend to ask this question. Even a child asks this question. So similar questions even the grown-ups ask in their respective field, whatever area they work on. So now, electromagnetic spectrum, some of you would have read about it. We use it every day. The visible light is very small spectrum. You can see the wavelength is very small, 400 to 700 into 10 power minus 9 kind of thing. So in angstrom, okay, 700 angstrom kind of thing. So it's so narrow. Then you see the other side, ultraviolet. Then you would have heard about infrared. For example, your mobile uh, remote, etc., and all works using infrared. Then you have this X-rays, which we use it for medical imaging. Then you have this higher energies, gamma ray. When the energy becomes higher, your wavelength decreases. On the other side, you have this microwave, radar, microwave, radio waves, and even the current, like AC circuits that we use, produces waves, but they are very, very small in energy. So the noises that you hear from, in your FM radio, etc., and all, actually those noises are from the space. People have studied those noises and they found it originated somewhere when the universe formed. They call it microwave background. So you have those things. So okay, so you can see different frequencies you see. So the information that we see, it's through optical. That means visible rays is very small, whereas we get information from the universe throughout all the energy spectrum, all the wavelengths. So here in this graph, it only goes up to 10 power 12. But if you go this side, it goes up to 10 power minus 17. And this side, it goes to 10 power 20. I don't know whether you can understand this 10 power. So 10, if 10 power 3 means it is 1000. 10 power 6 means it's a million. It is 10 power 9 means billion. 10 power 12 is, you call it tera, like terabyte means, TB means 10 power 12. But this is 1000 billion. So 10 power 20, 10 power 18 is billion billion. So 10 power, we have seen particles that has energy up to 10 power 20. So I work in cosmic rays. I worked in cosmic rays. This is the energy spectrum of cosmic rays. Use cosmic rays is produced by sun all the way to, like, we don't know, the candidates in very high energy. It can be supernova, it can be much, much larger structure, etc. So if you see, this is the flux. That means how much per meter square per steradian angle per second. So you have the flux integrated over time. So the highest particle enters on top of our atmosphere, 10 power 20, one particle per kilometer. So if you have a detector size of a kilometer, you can detect only one particle per year. So that's why to detect higher particles, they have detectors spread over kilometers. So in order to produce, this kind of particle, the source should be of very high temperature. Here, the sun is around 6,000 degrees, so it produces visible, and plasmas you can see in infrared, ultraviolet, etc. But for gamma rays, for X-rays, you need to have almost million times more than that for to produce an X-ray. Gamma ray, billion times. So it is, so to produce high energy, you need very high temperature, energy, to have that kind of energies. So we see in universe all kinds of things. Okay, so then how do we study? See, the camera doesn't produce that kind of photo. What the all the photos that we saw about, we'll see about the nebulas and other things that we saw, those are, maps or contours. So, and sometimes, scientists do many things to manipulate to get some kind of things that we can see. So here, the light that comes from a star, for our understanding, it's like a prism. When you pass through prism, it splits into different wavelengths. So that you pass it to use a detector and measure it. So you will know what it is made up of. So if you see the hydrogen, All stars has hydrogen. So each star has a unique signature. What it is composition is, you can see ferrous means iron, Na is sodium, H is hydrogen. So these are chemical names. In chemistry, you use this nomenclature. So you see the absorption lines. So from that, you know what that star is made up of. So here you see the stars, how bright the stars is. Luminosity is brightness. So sun is equated, the sun is taken as a reference as 1. Then you have, if a star is 60 times the mass of sun, no, it will be this much brighter. It also depends upon at what stage it is. So that also, let's see whether we can see it. So much information that we get it. So here, like for example, that satellite, it takes an image that's on this top left corner. It'll be dark. Then you process it, you brighten it, you see this structure. So when you pass through this prism and collect red, green, you use filter and collect the red, green, and yellow, the basic colors. Then you combine it, you get a colorful picture. So then you take different wavelength observation. So here you see in infrared, this is a crab nebula because it looks like a crab. So they named it crab nebula. So the radio, radio gives you this kind of image. Infrared gives you this kind of image. Visible gives you this kind of X-ray gives you. So when you combine, then you get the whole picture, because different wavelength gives you different temperature from which it would have been emitted. So when you combine, then you understand the profile. And when you see here you see a jet stream coming this way and this way, and gases and stars circulating around in a spiral way this way, and perpendicularly this jet is getting ejected. So then scientists put those things into simulation and see what it is made up of, why the structures form. The same crab nebula you can see in different wavelengths, like in radio, infrared, electromagnetic wavelengths, how it looks like. And gamma ray, you can see it's produced from a very narrow region, whereas in X-ray you have a spread, whereas ultraviolet is much bigger, and visible light bigger than ultraviolet, then it slows down. So the old remnant, like for example, radio is much smaller. So like that, we can also understand how this crab has grown up, this crab nebula is growing, and how it looks like in different energy and what are the sources, etc. So then we see this lifestyle of a star. So here we see, sun like a star. It grows in size as it becomes slower and slower in terms of as it runs out of fuel. Then it explodes. The inner one forms a white dwarf, and the outer one forms a, neb- a star forming nebula, and again a star forms from so this cycle gets repeated. Similarly, a massive star, it grows to a red supergiant in those diameters that we saw. Then it explodes as a supernova. Then a black hole gets formed, or a neutron star, and again the outer layers becomes a nebula, and again from it another star forms, either sun like a star or a massive star. So it also has a life cycle, but this life cycle is close to billion kind of light years we are talking about. So when we talk in terms of, in astronomy, in terms of light years. Okay, so now we saw this formation of the star. So this picture that we saw before, we can see different pictures showing the life cycle of the star in different at different times. So then, you know, so when we see an image, for us, It looks very wonderful. It looks like, no, some pillars. It's called pillars of creation. In a eagle and in a bigger nebula, that's called eagle nebula because it looked like a eagle. So now, what information do we get, and what does this picture represent? For example, you know, we saw the prism kind of thing or a grating. So from that, and we saw this elements, how the absorption line of different elements that we see. So here, in this picture, blue color, it's all overlapped. So the blue color represents oxygen, red color sulfur, green color nitrogen and hydrogen. We don't see those things because in this pillar, because it's a combination of different elements. So, and this ultraviolet, this blue color glow that you get behind it is because of the ultraviolet light coming from the cluster of young stars behind this pillar. And you see this cloud, it's broken or cut into these pieces, tear down in the middle, and the structures. That's because the winds from this background stars are slowly driving off these gases. So when a scientist does an imaging and see this kind of profile, they take a lot of time to study why it is so. So they okay, they are from this light they assume there should be some source behind. Okay, and why this source? Uh, and if that source, if it produces this kind of thing, how it will affect this kind of clouds? And then they compare it with experimental data. And only when the theory and the experiment agrees, then they know this happened because of this effect. Okay. So now scientific research is made up of two things: theoretical
I
science.
have a doubt.
Uh, can you
The
write it in
chat
the
is
chat?
disabled.
We will address it later.
The chat is disabled.
I didn't get you.
The chat is disabled.
Is
Okay.
disabled and somewhere is annotating.
Okay. Can you please, host, can you please enable the chat? Okay. And please don't scribble in the chat. Probably one person I saw typed all alphabets. So that's why. So that's why, that's why they would have muted it. So in any scientific research, we have theoretical science and experimental science. For example, Albert Einstein, he did a lot of theory work, theory of relativity. Then, and theoretical physicists are always strong in mathematics and physics. For example, if you give them a mathematical equation, they can visualize the mathematical structure, how that equation will form and structure. For example, if you give an elliptical equation, they can imagine an ellipse. So if you're strong in mathematics and physics, you can become a theoretical physicist. Whereas experimental science is more about hands-on work, building and designing your instrument, electronics, and even data collection, years of data you collect and you analyze. Then the practical problems you have to you need to learn to solve it. And if, as you if you have noticed, all telescopes are in remote places because the light, our light that we use, street lights, house lights, it pollutes the environment. Light pollution, we call it. So we cannot see with our telescope what we want to. And also we have atmosphere. So certain kind of measurement, you need satellites. Otherwise, ultraviolet and all, you cannot see it here. So similarly, infrared. So X-rays also. That's why you send X-ray telescope like Chandra. optical telescope like Hubble, and you keep your optical telescopes on top of hill away from light pollution, then you have radio waves. So radio can penetrate these things. So radio, the only pollution is another radio instrument. So, another radio, if someone broadcasts in some spectrum, for example, mobiles occupy certain spectrum. So scientists can only use those spectrums that is not used by others. Then only they can see. Otherwise, they'll start detecting your mobile signals. Okay. So now the biggest discovery in recent time is gravitational waves. It's detected by two detectors and later confirmed by another detector by Virgo. So here, if you noticed, okay, let me play again. Two massive, objects spin around each other and it creates a ripple, and the squares are called space time. So, it creates a ripple, and when they merge, it becomes much faster than the ripple. When once they merge together, the ripple stops. So this event was predicted in Einstein's equation more than 100 years back, but it took scientists 100 years to have the technology as well as build a detector to detect. And when they detected, how the signal looked like, it looked like this one. If you see a sound, the sound is like this. This is the LIGO Hanford detector, and this is Livingston detector. So you see these patterns. As it gets closer, the frequency increased, and in the merger it increased. Then it become almost back to normal. So this then they use lot of simulation to see. They put different types of stars, black holes, neutron stars, and they try to merge and see what kind of things it gets. For to detect this one, they have to find 1 part in 10 power 15 change in terms of nanometers, much less than atomic scale, to see this kind of change. So to have a detector of this one, it took them so much time. So then the next very recent in 2019, they detected the first image they took of the black hole. This is what the left hand top is, what the theory model is, and the right hand is what they detected, and this is what an artist impression looks like. So most of the time we see the theory model and the artist impression. This event on the right hand side, it took a combination of different telescopes that are across the world, Antarctica, Arizona, Mexico, and Spain, to devise a mechanism to measure. They took almost 10 years. And this object was 55 million light years. That means it would have taken 55 million light years to reach. So what we are seeing is actually what happened 55 million light years before. And it's the weight is 6.5 billion times of sun, and it took them 5,000 terabytes of data. Our laptops are 1 TB maximum. It took like 5,000 laptops, just the data alone. Then the processing part, it would have taken much more. It is such an important discovery, though it is a very faint, it looks like a donut. But this discovery led to the confirmation of black hole, which led to this Nobel Prize in physics in 2020 last year. So now, no, this is quantum mechanics. We have a standard model, which you would have heard about Higgs boson, etc. With Higgs boson, almost the standard model is completed. So this is what we see the universe. If the Big Bang has occurred, how the universe is expanding. We'll come back to this picture later on. So here, this is the detector in which one of the detectors in which the Higgs was discovered. Among these two detectors, this is one of the detectors, CMS, the other one is Atlas. So in nature, we have these four forces: weak, strong, electromagnetic, and gravitational. So now these are the fundamental building blocks. That means, you cannot, electron is alone. It's not made up of another particle as far as experimental confirmation. Whereas using these quarks, you can make a neutron, a proton, all other elements. Okay, and these are this forces, how they interact, etc., using these particles. So weak force is through W and Z, and strong force is due to gluons, and electromagnetic force is because of proton, and gravitational force is because of this graviton. So grand unification theory, they want to combine all these things so that one theory can explain everything. But this is in terms of quantum mechanics. But to combine all this theory into one thing, one theory that we can understand all the forces, they proposed string theory few years, some 15 or 20 years back. But in that, they need at least 10 dimensions to see one particle in different oscillation can produce all these particles. In such a kind of dimension, when we know only about 3 dimension, in x, y, z, any 3D object only we know, but 10 dimension or 10D object is very difficult to imagine. We cannot think about it because we live in a 3D world. If you consider time also, then four dimensions universe. So if the higher dimensions exist, then in theory, parallel universe is possible. So some persons sent questions before about parallel universe, etc., and even exoplanets. Whether alien life, or life is there in another planet. We saw from those pictures of those absorption line. People look for organic compound to see whether life can exist. Even a microorganism can exist in another area in our universe. So these are the things that helps us to understand. So till now we have not found one, but whereas we have found planets that are similar like Earth, where life can probably exist, but we have not till now seen this organic compound. Then, you know, this here we see this is what how the universe evolved. That's theoretical model. If it evolves because of gravity, it should actually shrink, whereas they see expansion. So when they see an expansion like this, universe is expanding. So when they put it into models, they found the normal matter or baryonic matter is only 5%, and 69% because of this expansion should be some dark energy that we don't understand, and people have no clue what it is. And we are not in a position to measure, so people are trying to understand this dark energy, and the rest 26% is dark matter. Dark matter, at least they understand because of gravity. You see this Milky Way kind of galaxy where stars are littered. It's like as if, bulbs around Christmas tree. Whereas these branches are these dark matter branches that helps together this lights, the stars. That's another kind of understanding. So people are trying to make detectors to detect dark matter. Once we can have some understanding, then they will proceed to understand dark energy. So the more you understand science, it produces more questions. And why it is so is something science cannot answer. So people, experimental physicists wants to be a theoretical physicist, and theoretical physicians want to be a mathematician. And a mathematician wants to be a philosopher. Philosopher wants to be a theologian, and theologian wants to be an experimentalist. So this diagram I saw when I joined my office in my boss's notice board. I was very much intrigued. And I later on I found how actually people, it kind of shows scientists mentality in physics, how. And there were some people who were who did work in all these areas. So now there are many hard questions we have, like what, how we can address from science, but why it is so, what it is meaning and purpose. Can we get it from philosophy and theology? Is it by accident the universe is created, or we see, formation, structures? We don't see random things. We see proper structures that obeys physics laws, that are governed by certain rules. So is it by intelligent design? So then, religious people, they say the religious book gives answer. Does they really address science? Like, for example, Bible, is it a scientific book? Okay, then the question is, what is the meaning and purpose of this existence? For example, mine is, am I by accident, or am I by, is there is a special purpose, special meaning to my life? So similarly, all these things that we see in universe, is it a special meaning? Because if sun is not there in its position and earth is not in its position, there won't be life. We won't be there. So, so who is this? Is it God who created? How do we know that God exists? So does, like this things that we see in the universe, does God also leave signatures in the universe? So these are the questions, one thinks about. So these questions comes under philosophy and theology. Theology is study of God. So if there is a God, since he created us, he should be higher intelligent than us. So he should be able to communicate to us. And God should be absolute. That means one who doesn't change, pure, perfect. And he should be the creator of time. So he should be beyond time. That means he should know even the end before the beginning. So Bible claims it is the word of God, and God speaks to us through his word. A higher intelligence should always communicate to the lower intelligent. Then what it says is, it is our sin that separates us from God, that we are not able to hear God's voice, and God is not able to hear us. And all of us are evil by nature because we offend others, and the punishment of sin is death. But since God loved us, he became as a Jesus, and he paid the price of our sins and rose again. So when we believe in him, that when we confess that I am a sinner and Jesus is God, and he died for us, and he rose again and asked him to save us from our sin, he saves us. So when he saves us, he should talk to us, because Bible says, my sheep hears my voice. So personally, being a scientist, for me, I cannot know when the universe started, because it's 13 billion years. I cannot see even beyond microwave background, because that permeates the whole universe. But similarly, if God is exists, he should speak to me. So, I've heard about my parents talk about God is a God who speaks. So, so when I was 15 years old, I wanted to have a long hair. So my parents, being conservative, they will not agree. So I said, okay, let me pray. Anyway, what God is going to say, then I'll say, I'll pray. God did not say anything, so I'm going to have this haircut. So I opened the Bible, and it
Okay.
fell on one verse, which it said, it's not good for a man to have long hair. It's not about man having long hair, but I understood God is a speaking God. Then when I attended this job interview, the director said this job is meant for someone. When I prayed, God said he will give me. No, and it so happened, for whom there's a temporary person they wanted to make permanent. That lady became pregnant, and she could not even come to the interview. So the job was given to the one who performed well. So similarly, in my lifetime, I found that God is a living God who speaks to us. So like how universe gives us information, when we confess our sins and remove through Jesus and ask him to save us and remove the sin out of our life, we can even hear God speak to us. So that's what the Bible says. See, then theology is study of God. This Bible is a scientific textbook? No, but it focuses on God's love and his desire to have relationship with his creation, especially humans. And Bible does give, information that it is God who created, and it's written in such a way that even a cave dwelling man as well as a scientist can understand. It's not written in a scientific language. So, but many times, the religious people interpret and twist it in such a way, it brings a clash with the science. So the problem is not with the interpretation, but with the source. So, if evolution is true, then we cannot, even if evolution is true, God created the universe through evolution, the original Hebrew language in which the Bible is written doesn't contradict, because the yom, what it interpret as a day, can also be a period. If a yom precedes with a number, then we say it's a definite period. But even in other places in Bible, it refers to a long period. So it's in the interpretation it matters. What is not scientific, we try what God says, I am the creator, and gives us basic information. We try to twist it as if it's a scientific textbook and try to interpret it. So that's where the clash between theology and science comes into picture. For example, evolution, we cannot predict and accurate even, but Bible has so much of prophecies that were fulfilled even after 1,000 years. Even outside of Bible, there are people who predicted and it so happened, which you cannot do it in an evolution process. And Bible claims, God knows the end from the beginning, and it says it's God who created, it's God who has sustaining the universe. And it also talks about the, class, this stars and its formation, etc. So, okay. So, yeah, thanks for listening to me. Now, yeah, since our time is running up, I would like to take the questions. Okay, do all stars are
Questions.
born in a nebula? I'm going along with the chat. You know, so, okay.
Can you
So if you
enable
see
the
the light,
chat? I have.
hello?
Can you enable the chat? I have more questions.
Okay, I'll come back to you. Like, for example, not all stars, in the sense, in the beginning, it was gas. Those gas condensed to form clouds, and the clouds formed stars. Then later on, the stars, of course, formed from nebula, but in the beginning, okay, or you can understand nebula as a cloud of gas. Then, of course, stars form from a cloud of glass. In the sense, stars needs matter to condense to form a star. And okay, it is said that after 5 to 8 billion years, the sun will go away. Yes. Okay, let me. Okay, screen sharing is stopped. Let me go. Let me share.
Sir, we can, okay, sir.
Okay, let me use this one to show you. Okay, where is the star forming? Okay, so here, we see a sun like a star becomes a red giant, then planetary nebula. So sun, after some millions of years, will form this kind of cycle. After a billion time, it can become another star. So it's a life cycle of star. Of course, first it hydrogen out of hydrogen. The hydrogen, nuclear fusion happens and it becomes helium, and then the helium, it starts slow, becoming red giant. Then slowly it's condensed to much heavier atom. Then this kind of much heavier object. Then planetary nebula happens. Then a white dwarf comes out. Then a nebula happens. Then a sun comes out of it. So this is the cycle of any star. So okay, that addresses Arna's question. Babin's questions also I have addressed. Okay, then how black holes suck things. Okay, so black holes. Okay, black holes or massive object. That means though they are small in size, they are it is very heavy. For example, neutron star, they say a spoon of neutron stars sand will weigh a ton, more than a ton. Black hole is much, much more massive. Maybe a spoon of black hole may weigh our Earth's mass or Earth's weight. It's so massive, so the gravitation is very strong. So what the gravitation pulls all, even the light, Einstein predicted even light is bent by gravity. Light doesn't have charge. It cannot be deflected by magnetic field or electric field. Whereas gravity, it bends. Here, this light we see, actually, this is like a disk. Because of gravity, you see the light from the behind getting bent, and it appears as if it comes from top and bottom. So anything, this black circle, the inner black circle, not the object, it's called event horizon. Anything that crosses this line gets sucked by this object, and they go and crash inside this thing. So it cannot escape. So when we say light, or when we say a black hole, any information from this thing cannot come out. So that's why it looks black. So because of gravity, it gets sucked in. So of course, black hole sucks everything because of gravitational force. Okay, so then is there a parallel possibility of parallel universe in a black hole? So parallel universe again. Okay, so black hole is a matter. So inside the matter, okay, if you are shrunk to a dust, okay, can that kind of dimension exist? But parallel universe happens in higher dimensions of bigger size. The dimension should be of the scale of our universe, etc. So most likely it's not, unless we are talking about a different kind of understanding. But in theoretical, they try to do different kind of modeling to see. But experimentally, we have not detected, or we have no idea about parallel universe, either in higher dimension or in smaller dimension as such in black holes. Okay, so are we the only intelligent creatures in the cosmos? Like we saw, we see this, what elements are there in different parts of the stars, etc. and all. We have not even seen the organic elements required for life in other places. So right now, it looks like we are the only people. So till we get a proof, we seem to be the only intelligent creatures on this planet Earth. Okay, so yes, so now you can ask through your mic also.
What is inside a black hole?
Yeah, matter.
Is there an end to the universe or is it infinite?
Okay, this is what we saw about this dark matter and dark energy. So, you have, Einstein had this equation which included cosmological constant. If that constant have particular value, how universe formed, it should come to an end. How it formed from, from the Big Bang, from a singularity, it should expand and again come back. Okay, please mute your mic, and when you speak, you can switch on the mic. So again, it should go back because of gravity. It should start attracting each other like black hole. Then it should start sucking each other, and we should be able to go back to this thing. So that is what, in one case, another case, it expands and it's constant. In another case, it keeps expanding. So what right now we see is, we observe that universe is expanding. So how do we observe? Because we saw a supernova the very early formation, that supernova expansion is slower than the expansion we expect at the present understanding. So that means our current expansion is greater than the expansion where the stars and galaxies formed. So this is why they predicted they this dark energy and dark matter. So when you put dark energy and dark matter, then we can understand this expansion of this universe. It fits the expansion of universe that we see. So unless we have proper understanding of dark matter and dark energy, it's very difficult to say about what will happen to the universe. But all the three cases in theoretically it exists. I hope that answers your question.
What came before the Big Bang?
Okay, so in science it says all the energy that we see, because energy can neither be created nor destroyed, right? Laws of
Uh,
thermodynamics. So it's all
I have a
located in a very
question.
singularity, which is single point, they say. So then they say the Big Bang theory. Okay, see, if you see, we cannot see beyond this microwave background. So what we do is, like the
Uh,
Higgs boson kind of experiment, we try to create that kind of huge temperature in atomic scale to see whether we can see this kind of particle production here. So what basically the theoretical understanding is, there is a single point in which all this energy are confined. So in mathematics, you can study about singularity, how they define to have that kind of energy. So when a quantum fluctuation happened, that led to this kind of particles, then gases and stars, etc. Okay, some kid wants to ask question. Please go ahead.
I have a question. Is Ceres, Eris, I mean, Ceres, Eris, Pluto, Sedna, Haumea, Makemake are dwarf planets?
Okay, Pluto is a dwarf planet in the sense, see the definition of planets. No, they
And
kept changing because you have a set of definition, and the more we understand about Pluto, sometimes Pluto they considered as planet. Then they said it's not a planet. Then again they said it's a planet. Again they said it's not a planet. So they have an astronomical society of astronomers. So when they meet
then
together in their annual conference, then they take up
then
this issue and see what are the candidates.
what is then what is astronomic measures?
Okay, astronomic measure has different units. The one is light years, another one is parsec, another one is astronomical unit. That is the distance between Earth, the mean distance between Earth and Sun. Because Earth goes around elliptical orbit. Sometimes it goes closer to Sun, sometimes it goes slightly far away. So they take the mean, and the mean distance of Earth to Sun is one astronomical unit, whereas one parsec is 3.2 light years. So light year is light taken, distance traveled by light in 1 year. Yes, please.
Is the moon 400 times smaller than the sun? Is the moon 400 times smaller than the earth and the sun's score is 27 million Fahrenheit?
Sir, what will happen if an
It's under that
astronaut
view
goes
in
near
which
Pluto? Sir, what will happen if an astronaut goes near Pluto?
okay, see,
I have
any object. So okay, there is a gravitational force. It depends upon the speed at which you go. Okay, suppose you land in Pluto. Recently, New Horizon, I think, flew by Pluto. So it has taken some measurement. So I have not seen its composition, but Pluto is very cold object because it's far off. and it's rocky and gaseous, the temperature is something we cannot sustain. But suppose we have a suit that helps. Like any planet, we can land there, but then we have to see what kind of atmosphere and what kind of uh, ground it has, whether we will sink in like a gas or it's a hard rock, etc. I have not looked into Pluto, but the thing is, its gravitational force is much, much, much smaller than Earth, because gravitational force depends upon the mass of it, mass and the size.
Is Pluto surrounded by a
Yeah,
poisonous
and radiation.
cloud?
Sir,
Uh, uh,
I didn't get you.
does a planet has to fulfill three things to become a planet?
Sir,
Yes, planets. See,
So,
one of the main thing
sir,
is it should orbit around sun, and all planets have, it follows certain laws of motion because sun is our center of these planets. For example, Pluto has a different elliptical orbit compared to other planets. So there are different set of rules, and right now I don't recall. Probably you would have seen. You can search internet; it will gives you what we classify as planet.
does it,
so is
does
Pluto
it,
surrounded by poisonous clouds?
Pluto has poisonous clouds. Okay,
No,
so
is Pluto surrounded by poisonous clouds?
if you give a Google search, what is Pluto made up of?
uh,
What is Pluto environment is? You will see what kind of environment is. For example, for us, all planets are poisonous in the sense we need oxygen to breathe. We don't have oxygen atmosphere in other planets.
sir,
uh,
sir,
Yes.
Sir, why did
sir,
Pluto got
sir,
does
Okay.
it rains diamonds on Jupiter?
Okay. Jupiter is a gaseous planet. We have not still studied about the
But
inner
does
core.
diamonds rain on?
So we have no idea whether diamond is there in Jupiter.
Okay, children, I think we are running short of time. Okay, so
Okay, so all the questions that you have, you can send it to the host. Uh,
yeah, you can WhatsApp to the same ID in which you receive the link. Okay, you can compile your questions and send to us so that we will take all the questions and send to Sam uncle. Okay, he will address you back whenever he finds time.